All right, start talking our way through these. If you're not done with either of them yet, that's okay. We want to get our thinking going beforehand so that you have a chance to mull over it for a little bit before we go over it as a class. So I have 2 logs over on the left. Do I want 2 logs and then a number that doesn't have a log? Is that the way we go about solving it? No. I want how many logs? Just 1 log. Morning, Betsy. So the first thing I want to do is take this and condense it, which means only 1 log. What do you notice in between those 2 logs? Addition. So when I go to condense this, addition turns into what operation? Multiplication. So I'm still going to have log base 2, and then I'm going to multiply x minus 2 times x plus 1. And I'm putting these brackets around it just so that I know that those 2 things got multiplied by each other. Keep what's after the equal sign exactly the same. I'm going to go ahead and multiply those pieces in the brackets together. I'm going to need to use some double distribution. And since I don't have a lot of room right there, I'm going to bring it off to the side. So when I use double distribution, this x right here, this has to get distributed to both of these parts. What's x times x? X squared. What's x times 1? 1x. And that's a positive 1, so I have a positive 1x plus 1x. So that's single distribution because I took one thing and distributed it. I have to do the same thing here with this negative 2. That also has to get distributed to both parts. Negative 2 times x is what? Negative 2x. And negative 2 times 1? Negative 2. Are there any like terms that I need to combine together? Yep, positive 1x, negative 2x. So I have x squared, because that doesn't have a like term. What do I get when I combine these 2 like terms together? Negative x, or negative 1x. And then I'm going to bring down my minus 2. So this is what I get when I multiply those 2 sets of parentheses together. You guys okay with that so far? We condensed, we saw the plus sign, and that meant multiply. So I had to multiply those 2 binomials together, and that meant using double distribution. Do I have it down to just 1 log? Yes. So now I'm going to use my triangle. What is the base of this log? 2. What's the argument of this log? X squared minus 1x minus 2. So what goes up here on top? Positive 2. This is the part that comes after the equal sign. So I'm going to take my base of 2 to the power of positive 2. And that's going to be equal to my argument, which is x squared minus x minus 2. Do you guys see anything in that line there that we could simplify or put into our calculators? 2. Yeah, 2 to the power of 2. What is 2 to the power of 2? 4. So I'm going to bring that up around here, and I'm going to rewrite that as 4. So 4 equals x squared minus x minus 2. Close. Super close. What kind of equation are we looking at here? Quadratic. There we go. This is quadratic. And the first thing we always have to do with quadratics, if there's an equal sign, is make sure that it is set equal to 0. So I'm going to subtract 4 from both sides instead of adding 2 to both sides because I want that 0. 0 equals x squared minus x minus what? 6. Now that I have it set equal to 0, what do I look for next? GCF. Do we have a GCF? Nope. So I need my x. What do I put up on top? -6. We multiply a and c together. What do I put down on the bottom? -1. Guys, I need you to turn the music off. I can hear it. What multiplies to -6 but adds to -1? -3 and 2. Do I need to draw my whole area model, my whole box out, or can I use the shortcut here? Shortcut. How do we know when we look at it whether or not we can use the shortcut? A is 1. So right here, in front of my x squared, our a value is equal to 1, and so we can use our shortcut. When we use the shortcut, we have 2 sets of parentheses, and both set of parentheses gets an x in it. And then those 2 numbers that we found, so I'm going to circle them in light blue, this -3 and +2, that's what we put in there with it. So I'm going to have x minus 3. The 2 is positive, so I put x plus 2. Once I have things factored, what do I do with each of those factors? Set them equal to 0. So x minus 3 equals 0. X plus 2 equals 0. How do I solve them for x? Yep, plus 3 on both sides. So I have x equals 3. With the other one, I'm going to minus 2 on both sides. So x equals -2. Am I done? Super close. What did the directions say to not forget to do?
Check for extraneous.
Check for extraneous solutions. What does that mean? Yeah, I need to check to see whether they are valid or not. How will I know whether or not they're valid? Yep, we're going to put it in the place of x, and I'll know it's not valid if what happens? If I get a negative or if I get a 0. Anything other than a positive number. So let's check x equals 3 first. I'm going to put it up here. 3 minus 2, positive or negative? Positive, so I like that one. And then I come over here, I have to check in both. 3 plus 1, am I okay with that? Okay, so what does that mean about x equals 3? Valid. All right, I'm going to use a different color over here. X equals -2, so I'm going to come over here. -2 minus 2. That's a negative, right? So what does that mean about this answer? It is extraneous. Extraneous. It makes an argument negative. Makes one of my arguments negative, and so I have to throw it out. If it's not a valid solution, I did my math correctly, but I got something that doesn't actually work, and so I have to throw it out. What questions do you guys have for me on number 1 before we look at number 2? Because number 2 is very different. A totally different type of thing. Yes, ma'am?
Can you cancel the log out first and distribute the
let me rephrase your question and make sure I'm understanding it correctly. Are you saying that, like, right back here, could we have done, 2 is my base, this 2 is my exponent, this thing in here is my argument, and then we could have rewritten it as 2 squared equals x minus 2 times x plus 1? Is that what you're asking?
No, like, you cancel the log.
Okay, I think I understand a little bit better. Let me, like when we had problems, something like that. And are you asking, can we just like cancel the logs out there?
Sort of, like, okay, you know where it has like the brackets around the x minus 2 and x plus 1?
Mm-hmm.
Can you cancel like the logs base 2 and then you like distribute all of that?
So I think the word that I'm getting hung up on here, and it's I'm not trying to be overly critical, but our language matters, and I just want to make sure that I'm communicating clearly. So we don't ever actually like cancel our log out. We're rewriting it. So when I rewrite it as an exponential, exponentials undo logs. So I guess like thinking about it like that, yes, we're getting rid of the log. But I can't, back in this step right here, I can't just get rid of that idea and then move forward.
No, I know, but like I'm saying, like you put the 2 on both sides, so it cancels.
Like this?
Yeah.
Yes. And that is something that I believe has been gone over in the videos, and that's called exponentiating, which is another way of achieving the same end result as rewriting it as an exponential. When we exponentiate, you would have, basically you're putting this base of 2 in there, and then yes, that would make my log cancel out, so it would leave me with just this part, and then I would have 2 to the power of 2. So this part is here, and all of this part right here, that's what I have written down here. Yes, absolutely you could do that. Very good question. All right. Do you guys have any other questions for me on number 1 before we move on to number 2? Okay. Number 2, I want to write a system of equations. Since I'm writing a system of equations, I know I need to write equations, which means I'm going to need equal signs. Tell me what we know in this problem. Do we have totals or do we have starting amounts? Totals or starting amounts? Starting. Says Darius collected 50 pieces. That's not the end because he went on to do what with his candy? Eat it. That's why those 50 pieces aren't an ending amount. It's not a total, a final amount. That's what he collected at the beginning, and then he did something with it. So whenever I have a starting amount, a beginning amount, my equation starts with a y equals. I write it in slope-intercept form. This is my starting amount. Thank you. And the m right here, that's the rate. So what is Darius's starting amount? 50. Positive 50 or negative 50? Positive. He had these pieces of candy. So I'm going to have a plus 50. And then he's eating them. What happens to that total amount of candy if he's eating things? It decreases. How do I show that in an equation? Yeah, minus 2x plus 50. Or if you wanted to write it the other way around, he starts with 50 pieces and he minuses 2 each day. Either way of writing this means the exact same thing. but you do want to write it in y equals form. What about for Darius's little brother? 345. Is this another y equals? Yes. Because 345 is the starting amount, and what does he do? Eat 5 each day. So 345 minus 5x. Or if you wanted to write it in y equals mx plus b form, it'd be negative 5x plus 345. The starting amount is a positive thing in both of my equations. And what they are consuming, the rate at which they're doing that, is the negative thing. What does x mean here? The days. So what does y mean? How much candy? Y is pieces of candy. Because on day 0, if I put a 0 in there for x, you get 345. That's how much candy he started with, right? On day 1, it'd be 345 minus 5, so he'd have 340 pieces of candy. We substitute in for days with x, and we find amount of candy as our output. All right, we are going to practice with some story problems today. The video yesterday was about applications. We're going to keep rolling with applications today. We're going to start on page 150. 150. So this is a real application of logarithms. There's many, many, many real-world situations that use logarithms. I think we've already looked at a couple examples, and there was one in the video that was talking about earthquakes. When they measure earthquakes, is a 9.5 strong or weak? Strong. What about a 2? Weak. It's actually really weak in comparison to a 9.5 because it's this logarithmic scale. pH is another thing that works like that. Do you guys know what pH is?
The pH scale?
Yeah. What is that?
Oh, it's when it's like it tells you if you have acidic, neutral, or is it basic?
Yes. Yes. It tells you whether something is acidic, whether it's neutral, which is pure water, not necessarily tap water, but purified water, or a base. Absolutely correct. What happens when you mix an acid and a base?
What's that mean? I feel like
Honestly, it's been too long. I was hoping you could tell me. What happens when you mix an acid and a base?
it's still acid.
Probably depends on how acidic and how basic. Have you guys ever done like the little strips in science class where you test to see if something's an acid or a base? Yeah. So here's the formula that they use to determine the acidity of something. The acidity is based on the hydrogen ion content. How concentrated is this hydrogen ion? If the pH value is less than 7, then we consider that to be acidic. So if our pH is less than 7, it's an acid. If the pH is greater than 7, then it's a base. What about if the pH is exactly 7?
Neutral.
That's neutral. So pretend you're in science class and you test some apple juice, and instead of getting a test strip, you are asked to test the hydrogen ion content, and this is what you find. 0.0003. I want to find the pH value, and I want to know whether it's a base or an acid. Which of the variables in that equation mean hydrogen ion content? H. So this right here, I'm going to put this number in here. So the pH is equal to negative log, and then I have 0.0003. What is the base on this log? 10. Is that one of the buttons on the calculators? Yes. This is called the common log, and it's on our calculators. So I just need to grab my calculator and plug that in. You can do this from the Desmos application, or you can come up and grab a calculator from me, but you want to type in the negative sign first, and then you're going to push the button that says LOG. That is common log, and it always has a base of 10 on our calculators. Come up and grab a calculator if you need one. I want everybody to practice putting this in. Make sure you use the negative key and not the minus key, because these calculators get picky about that. So negative, and then the button that says LOG. On the yellow calculators, that's going to be up near the green key. And then 0.0003. Give me 2 after the decimal point. So what do we have? Is there a whole number, or does it start with a 0? Whole number. What's our whole number? 3. And then give me 2 numbers after the decimal point. 52. So there's our pH for apple juice. What about the base?
Yeah.
So when you do common log on your calculator, the base is already there.
Okay, so
If you need a base of 10, that's what's on the calculator. To get to it here, you're going to push, do LOG. There you go. And then go back to the numbers. And then, and you're going to need a negative in front as well. My apologies. So is apple juice a base or an acid? It's under 3, so it is acidic. Or under 7, yes, thank you. My apologies. I saw the whole number 3 there, and that's what came out of my mouth. This is an acid. Let's look at part B. Lemon juice has a pH level of 2.2. So here's the pH level of 2.2. I want to know what is the hydrogen ion content. So here's my formula. pH is equal to negative. This is common log. You told me that's base 10 of our hydrogen ion content. Where do I put that 2.2? After the log? That's my pH level. So this 2.2 right here, that goes in here. It's going to take the place of this. So I'm going to have 2.2 equals negative log of H. Is my log isolated? No. What's in front of it that I need to get rid of?
Negative.
The negative. So let's divide both sides by -1. So So that cancels my negative out. So now I have negative 2.2 equals log of h. Is my log isolated now? The log is isolated. When I look over here on this side, it's just log with my argument. Yep, log-based argument is what I mean when I say is my log isolated, because I can't ever just have those 3 letters by themselves. When my log is isolated, that means I need to use my triangle so that I know where to go from there. What is the base? 10. Anytime we have a common log, our base is 10. What's the argument? H. So what belongs up here on top? Close. Negative 2.2. So how could I rewrite this? Yes. 10 to the negative 2.2 power equals h. Can I pop that in my calculator now? Yes, I can. Put this in your calculator. This comes out to be really small, so when the zeros stop on the calculator, I still want 2 numbers. So h is equal to, it's 0 point, how many zeros are there? 2 zeros after the decimal point, and then give me 2 more numbers. 6.3. Some calculators will give this back to you in scientific notation. It'll say 6.3 e negative 3. And what that means is 6.3 times 10 to the negative 3rd. These are the same answer. One is in scientific notation. And the other is just written as a normal number, no scientific notation there. All right. We are going to go over to page 152. Because the video did page 153, we're going to do page 152. This is called the decay function. This a in front, that's my starting amount, and we kind of used this a little bit in our exponential unit. We were introduced to this idea in our exponential unit. A is my starting amount. What's E? Does anybody remember what that E is? Is it a variable that has a meaning? No. This is Euler's number. It's about 2.71. We have a button for it on our calculator, but that's about how big it is. What do you think the capital, or not capital, what do you think the letter T means here? Time. And this K right here that is made negative, this is called our decay constant. And anything that decays over time has its own decay constant. All right, plutonium decomposes radioactively. Its half-life is 180 years. So what that means is it takes 180 years to have half the original amount left. And they want me to find k, that decay constant. And it tells me my initial amount is how much? 40. Where does that go in this formula? In for a. Okay, so I have f of x equals a e to the negative kt. So in the place of a, I'm going to put 40. E is not a variable. E is a number, so it stays e. I'm supposed to be finding that decay constant, so I keep the negative k there. And I need to fill in these other two pieces. F of x is my ending amount. Well, if I started with 40, how much am I going to end with if we're talking about a half-life? 20. 40 cut in half is 20. That's where we got this 20 from over here. Do I have an amount for time? 180 years. And k is getting multiplied to that. Whew. What am I trying to solve for? K. Where is k? Yeah. K is part of my exponent. So I need to isolate the thing that is an exponent on. The k is an exponent on my base of e. So what can I get rid of as I isolate this? The 40. How do I get rid of that 40? I divide it. 40 is being multiplied, so I'm going to divide by 40, divide this side by 40. What's 20 divided by 40? 0.5. So 0.5 is equal to e to the negative k times 180. Are you guys okay if I rewrite negative k times 180 as negative 180k? That's like doing negative 1x times 180. That'd be negative 180x. Same exact idea. So I'm going to swing around with this, and I'm going to write that over here. 0.5 is equal to e to the negative 180k. K is still part of my exponent, right? When I use logs, that's how I get exponents all alone on one side. What is the base here? E. My natural log is my base. What's my exponent? My exponent? Negative 180k, and that's what goes up on top here. So what's the argument? 0.5. So now I want to write this as a log. Log means I want these pieces here. So I'm going to have log base e of 0.5 is equal to my exponent. What's a better way of writing log base e? ln, natural log. So ln of 0.5 is equal to negative 180k. How do I get rid of that negative 180? Divide. I'm going to divide both sides by negative 180. And now I need to grab my calculators. We've got the ln button on there. You need to do ln of 0.5. These calculators are automatically going to open up parentheses when you push the ln button. You need to close them before you divide. If you don't close them first, it thinks you want to divide by 180 or negative 180 as part of your argument. And it won't give you the right answer. You said 0 point what?
0.038.
Yes. K is about 0.0038. We're going to skip down to number 5. And I'm hoping that you guys notice a lot of similarities between what we just did on 4A and what we're going to do on number 5, part A. What's happening in number 5? Deposit of $1,200. So this is my starting amount. What happens to it over time? Yep, pays 5% interest, so I do 5 divided by 100, 0.05. Here's my rate. Yes, compounding continuously. A equals P, there's that number E again, to the power of RT. How long will it take for your money to triple? What does triple mean? Times by 3. So what am I timesing by 3? The deposit. How much was the deposit? 1,200. What is 3 times 1,200? 3,600. So this is my ending amount. All right, so A equals P E to the RT. What can I sub in and where? A, this is my ending amount here. What did we say our ending amount was? 3,600. Do I have an amount for P? Yep, 1,200. Do I have an amount for E? No, that's a number. Do I have a rate? 0.05. And then we're looking for the time. Do you guys notice how this looks very similar once I sub the numbers in to what we were just doing? I've got number equals number E to the power of number and a variable. What do I want to do first? Divide both sides by 1,200 because I want to isolate that base. What is 3,600 divided by 1,200? 3. Our money wanted to triple, and so we got a 3 when we divide. 0.05t. Here's where I want to pull out my triangle. What is my base? E. What goes up here? What's the exponent? 0.05. T. Yep. Soraya, it's not the 3 because when I have it written as a log, the exponent is the thing by itself. I don't have a log right here. I'm trying to get it as a log. But when it says an exponential, that argument is over here. So now I'm going to write my log using these pieces. So I'm going to have log base E of my argument. What's my argument? 3 is equal to my exponent. What's my exponent? 0.05t. We know a better way of writing log base E. That's ln. How do I get t all by itself? Divide both sides by 0.05. I don't want to divide by the t because I want the t to stay there. What do we get? So remember, you want ln 3, close your parentheses, divided by 0.05. 21.97 is equal to t. What does that mean? Yeah. Takes almost 22 years for the money to triple. Almost 22 years for that money to triple. All right. You guys have homework that's due for me on Monday. Homework 3 is due Monday morning. Your test is next Friday. Test is next Friday. There's one more thing that we're going to look at, practicing the same skills. We'll do that Monday and Tuesday, and then we'll review Wednesday and Thursday for your test on Friday. And then we have one more unit before spring break. All right? I hope you guys have a fantastic weekend. The weather looks like it's going to be gorgeous tomorrow. Forecast, when I looked at it this morning, said 72 tomorrow. Get out and enjoy it. Temperature drops on Sunday, not freezing, but not as warm. So enjoy your day Saturday.